Hey there, welcome back to another video. If you're new to the channel, thanks in advance for watching and hope you subscribe. So, got a 480E late model center loop design. It's a Jasper remanufactured transmission. It's got about 40,000 miles on it, and the shop that brought it to me said it was pretty much slipping in every gear. It's also making noises. So we're gonna open it up and see what we can find out, see what's going on inside of it. I'm also curious to see how Jasper rebuilds their 480Es, what they replace, and more importantly, what they may not that they should. So let's go ahead and get started. Alright, if you have the converter handy, go ahead and inspect the hub visually and give it a good, once over physically to see if there's any grooves cut into it, as well as any unusual wear that would indicate it made hard contact with the pump bushing. So, any grooves cut into this location here are going to indicate a leak was occurring, in the front seal location of transmission, and loss of fluid if left unchecked. In other words, where the driver wasn't topping it off consistently, would obviously result in hard part damage and functional issues. If it was, allowed to progress to enough of a severity. The other thing you need to be aware of is signs of hard contact between the hub and the pump body bushing. If that was happening, that could result in damage to the priming crescent in the pump, and we'll check this one out once we have the pump apart to see, because I see some evidence that that was happening here. And if it's only happening on one side, just like this, that could also indicate excessive wear in the engine's main bearings. So these are things you want to look out for, especially if you have the converter present, so you can, kind of already going into it, have an idea of what may have driven whatever symptoms or problems, failures that occurred inside the unit. Alright, first things first, we'll go ahead and remove the extension housing. So 15 millimeters, 6 bolts. And I'll take out the seal later. So, two-wheel drive units starting in 04 and up, the extension housing in the area of the bushing changed. And this is, I think, a 2006 model year unit. I'll double check the tag if it's visible. We'll take a look at it in a second. But the inner diameter here for the housing itself got wider. So the extension housing bushings that come in all the bushing kits will not actually have the correct bushing for those 04 and up units. You need to buy that bushing separately, and it's a Durabond bushing. If I have it handy, I'll flash the part number across the screen, but suffice to say, this bushing in here will not come in the bushing kits. So, all two-wheel drive units have the pinhole seal here. The 4x4 units do not. This is in park. Let me go ahead and take it out. Okay, it spins nice and free. It's always going to spin, I would say, about 4 times as easier, or it's going to take 4 times less strength and effort to spin it in the direction of engine rotation than against engine rotation. That's perfectly normal. If it doesn't spin at all, especially if you have a slip yoke on it, then that would indicate some sort of hard part failure inside the case. Alright, these 2 speed sensors, input-output, are 8 millimeters each for the bolts. These are missing. So 91 through 93 4x4 480Es used 3 speed sensors in the command and control framework for the transmission. Okay, they had the input speed sensor, the output speed sensor, and the vehicle speed sensor, which was in the transfer case. So if you're looking for a used 480E and you have one of those model years, you're not going to be able to use anything outside of that 91 to 93 model year range, at least not without tuning the ECM or PCM for those years to not look for all 3 speed sensors. Okay, so when it comes to the front of the transmission, first thing you want to do is grab up on the input shaft and physically assess front end play. Okay, and it may be a good idea to just tap on the output shaft so that the rear section is loaded while you do this, and then hold it. So the amount of end play that this seems to have is about what you would expect. The reason being is that you'll have a snap ring on the other side of the shaft that holds the input shaft to the overdrive carrier assembly, and that for factory shafts is worth about 25 thousandths of slop or travel between the snap ring and the snap ring groove. So that has to be netted out of your measurement and then whatever that measurement is, less the rear end play, is your net front end play. So rear end play is 4 to 22 thousandths. Front end play is 5 to 25 thousandths. You never ever want more end play in the rear than you have in the front net of the snap ring. Okay, my target range is anywhere from 7 to 12 thousandths in the rear and about 12 to 20 thousandths in the front. And again, those are net figures. So any late model center loop design 97 and up, the first thing you have to do is take out this rear cooler line fitting. If you fail to do that, you'll never get the rear gear train out of the case. Okay, you may be wondering what the hell is holding it in. You remove the feed bolt for the center support, you remove the snap ring, but it still won't come out. And who knows, you may resort to drastic measures and do desperate things because you can't figure it out. Well, it's because that cooler line fitting goes into the center support. Okay, this portion of it penetrates into the center support, and it will hold the support and everything else behind it in the case, preventing you from removing it. So note the O-ring there. New one will come in the kit. All right, so let's see if we can locate the ID tag. So normally it's on this side, but it may have been removed. Right here is where you would usually find it. So we know that due to the fact that it has a hold location 12 o'clock position, it is a 99 and up unit, and the 99 up units contain several engineering changes relative to their predecessors, so you just want to be mindful of that. From the point of view of interchanging transmissions as an entire assembly, anything 97 and up will work, as long as you're swapping out another center lube transmission. But if you're trying to interchange individual parts, like the gear train or even the pump assemblies, then you need to know what the differences are, 97, 98 versus 99 and up. Because if you don't, and you mix incompatible parts with each other, you're going to have a lot of problems. So let me see if I can get this thing off. So this is going to be your vent tube. Anytime fluid is venting out of here, that would indicate some sort of either overfill condition inside the transmission or an underfill condition. So overfill or underfill. If it's overfilled, the excess will vent through this tube. If it's underfilled, thermal driven pressure will force even more fluid out of that tube, and it'll be kind of like a horrible positive feedback effect to where transmission may actually end up burning down because it's run low on fluid. So those are all things that you want to keep watch for when it comes to 480Es. Okay, wiring harness. You will never reuse the wiring harness in these transmissions. Okay, it just will never happen, because if you do, you run a major risk of having the thing go into limp mode because it's leaking through the connector, which is very common, or it's just simply shorting out, which is also very common. So just be aware. Okay, torque converter clutch O-ring. If the torque converter was slipping, it could be because this O-ring here is worn or flattened. Okay, this one feels like it's, fairly supple. I mean, for a unit that has only 40,000 miles on it, for it to be slipping like that is not very good, at least on its face. But one thing that could cause any transmission, regardless of age, to be slipping or behaving kind of erratically is engine management sensors that are failing. So for example, your mass airflow sensor. If the mass airflow sensor is not working, it's under-reporting the air charge to the ECM. The ECM will then undermix the air-fuel ratio, and it will also under-pressurize the transmission, so you will not have sufficient line pressure rise to meet the demand that the engine is placing on the transmission. Alright, that fluid stinks. Nasty. So, all bolts, 10 millimeter, there's 17 of them. You get a socket extension here. See what this thing looks like. So I'm not sure exactly what vehicle this thing came out of. I think it was like a Silverado 2500 HD, something like that. I mean, the shop told me I took it in about 3 months ago. So only now I'm getting to tear it down and see what I got, see what I'm working with. Alright, should have a reusable gasket. See if the pan is hard and fast to the case. Of course. Make sure I got all my bolts. I do. Alright, so I say this in other teardown videos, I'll say it here. If you need to use a pry bar or a screwdriver to tap the pan off because it's held in fast, you know, by RTV or just, you know, due to heat bonding, always go on the pan side of the gasket at a bolt hole location. Okay, that'll ensure that you don't damage the pan or the case's pan rail surface. So it doesn't really matter what bolt you go, as long as you don't damage the either the pan or the case, you'll be fine. Yeah, that's just really on there. So since back used RTV, and what we see here at the bottom of the pan matches the drivability symptoms that were reported to us. Nasty ass gasket. This will not be reused, regardless of whether or not it was designed to be reused. It is disgusting. I'll just put it here for now. So late model filters are different than early models. So you don't want to use an early model filter on a late style and vice versa. And here the differentiator, early versus late, is traditional rear lube design and center lube design. So 91 to 96 is considered early or first gen 480E. 97 and up I consider to be second gen 480E. $10mm bolts. Let me get a screwdriver. Alright, don't worry about it if you break tabs off the harness. I mean, they're going to be brittle. So, again, it's a Jasper unit, and what I'm seeing here indicates that they actually reused the harness and the solenoids. This is OEM General Motors. This harness and these solenoids were installed at the factory. They did not replace the harness or the solenoids. Okay, this is your trans temperature sensor. If you're not familiar with 480Es, one thing you want to do is just take a picture and note where the harness keepers or locators, containers, whatever the hell you want to call them, which specific bolt hole locations they are located at. Okay, valve bodies 97 and up are all interchangeable. There are no material differences between them. You got to be careful though with the early stuff. 91 to 93, actually 91 to 92 are said to be interchangeable, and then 93 through 94 are another vintage, and then in 95, this doesn't affect interchangeability, but the valve body itself underwent a small design change, and that has to do with the diameter of the sleeve for the third reverse check ball. That capsule, it changed. Sonex makes an O-ring and end plug kit for the 95 and up. So if you have a 95 and up valve body, and when you're doing your vacuum testing, it tests weak at that location where the third reverse check ball and the lower reverse check ball O-ring is, and that's what you're testing, and it's failing, then you can purchase Sonex's O-ring end plug kit and fix that. But if you have a 94 and back, that's not available to you because Sonex doesn't make anything. Now maybe somebody like Central Valve Bodies does, and you'll be able to remediate that condition, but last time I checked, they didn't make anything either for it. Alright, this small tube lubricates the rear case bushing in the 91 through 96. They had a very large tube that went from here at this location in front of the valve body back to the case. So again, one of the many characteristics that renders those two generations of 4-lady valve body not interchangeable with each other. Alright, pressure switch manifold. These were all the same all years. All years, same part. Alright, you can service the pressure switch diaphragms on these things, and the seals both will come in the kits, or at least depending on what kits you buy. But this one is junk. I mean, you can see pressure switches broken off onto the valve body. So into the trash with it. So it's your whole valve body assembly. So Transtech gaskets. 8mm bolts. There's 6 of those. So we'll just take these loose as well. That, what you saw there, was a consequence of spring tension. 91 through 93 housings were different. They had what's called the torque signal compensator valve. Or maybe it was 91 to 92, I think 93 they deleted it. One of those 2 years. But in this location right here, they had a torque signal compensator valve that was part of the EPC cleaning cycle and process that the ECM would periodically run, on these transmissions to clean that EPC filter. That filter was the vented style, which meant that the valve bodies for those years, 91 to 92, were not vented. They were what's called closed. And there's an EPC balance hole that has to be in the spacer plate if you're going to retro a 93 through 2002 Borg Warner EPC, or maybe it's 93 to 02 or 04. So let me repeat that so that it's a little bit clearer. So on the spacer plate you have an EPC balance hole. And I'll put a diagram because this is filthy, but that balance hole is present on 91 and 92 model year units. And that was part of the EPC torque signal compensator circuit so that it would allow for the EPC to be periodically cleaned automatically by the electronic control module, or engine control module, excuse me. So, a lot of evidence of heat damage. I mean, gas bonding to the spacer plate is a classic sign of transmission overheating. You want to check your accumulator pistons. I don't see them crack too often, but I always replace them if I'm not running a block-off plate. But, it's always a good idea to actually run that block-off plate if you're doing anything high performance. So if you're dual feeding the direct clutch, that's usually done in combination with running the 2.3 and 3.4 accumulator block-off plates that are available in the aftermarket for these units. Okay, this is the later style or later version of this pin. Let me go get the punch. Alright, so you can smack this out with a regular drift punch and a small hammer. And this one is pretty well stuck in here because what went on with the unit. Here it comes, and the piston should come out with it. Alright, and then to extract this, you're going to need to put air right there. I don't have my air on there, so that's not going to happen. Alright, so let me drain this valve body a little bit. So it looks like we have yeah, pressure switch material and parts still adhering to the valve body. I mean, I disassemble this whole thing and test it. I think I'm going to film the testing of this video or this valve body on the Sonic's back test machine, simply because I don't have a 4LADE valve body test video where I'm testing the valve body at, independent of that test plate. And again, for those of you that build these transmissions or otherwise have an interest in the goings on and what's happening in the 4LADE space, I spoke to Sonic's about 3 or 4 months ago, and we had talked about the test plates, because I was asking them if they had any other test plates available for the different transmissions that I work on. And it turns out that those test plates are apparently not selling all that well, not moving. So he mentioned that they're likely going to discontinue production. So if you do want them, I'd grab them up now. That was as of about, I want to say September, October. So Sonic's is a great company to work with as its trains go. They readily answer questions. They provide, whatever information that you need about either their products or, help you kind of diagnose problems, answer technical questions, etc. So if you're working on transmissions, they're great to talk to and, a good resource for you. With that said, I would not run a Transgo shift kit in any of these transmissions, just simply because there's too many things that they include that I would never use. One of them being that EPC relief mod. A lot of problems reported with that thing. The mechanism that is kind of spring loaded that holds it all in place. The part that does retain it would fail, and that would cause massive pressure loss in the electronic pressure control circuit. Let's see if I can get this stupid ass E-clip off. There it goes. Yeah, it looks like there's 2 E-clips. 2 E-clips! I've never actually seen that before. So always a time for firsts when it comes to transmission building. So this is a second design, low reverse piston. If you're doing anything high performance, high RPM, a lot of power, I would not reinstall the stock piston. I would install a Sonic's billet piston. They're like $70 or $80. And these will sometimes break on you under a lot of power, especially if you're doing burnouts and manual low, as part of your racing. That will cause that piston to fail under the wrong or right circumstances. So whenever anything fails, it's always wrong. So all this crap to the side. This thing should just come out of there. Nope, this is holding it in. Nope. Gotta get that out of the way first. So we have what is an unusual parking rod guide. Not seen one of these before. So maybe that's like a Jasper special. No, we have the regular parking rod guide underneath of it. So I don't know what the hell the story is with this thing. If you guys know, you've seen them before. Maybe it's an aftermarket product. By all means, please let me know in the comments. I'd appreciate it. Anytime I see anything unusual that I've not seen before, I'm always curious to know a little bit more about it. What a mess. This fluid stinks. Absolutely stinks. Alright, so your coast band servo changed with the band design, and I believe it was 1999. Wider band, so you can retro that band and servo as a service pack to any prior year. You just have to retro both the band and the servo together. You can't just do one of them. Can't have one without the other. Alright, so we got that out of the way. 15 millimeter on your selector shaft nut. You grab up a wrench. All right, and then as far as that little retainer that is nail-like, it looks like a finish nail, you just want to be real careful with this thing and pry up on it gently. Straight out, that's the main thing. You want to be straight up or straight out with it so that you don't break it off into the case. What you saw me do there is perfectly fine as long as the pry bar is positioned such that it's pushing it straight. If it's cocked sideways a little bit, well, that thing's going to break off in the case and then you'll be in a world of hurt, because it is very, very difficult to get that thing out. And I did that once, took it to machine shop, and both they and I were present while they were trying to get it out, and they have every tool you can think of, and it took them like over an hour to get it out. And that's a machine shop that, like I said, has a lot more tools and capabilities than I do. All right, so Torx 40 for your overdrive feed bolt, and then your center support feed bolt is a 3/8 12 point. This gets 125 to 140 inch-pounds, somewhere in there, maybe 150 inch-pounds. I think I typically do 12 foot-pounds, or it's like 144 inch-pounds. This is 32 foot-pounds. All right, so when you have this situation, don't even bother with the impact. So I'm going to use an impact driver, just a manual one, and see if we can get it out. Somebody way over torqued that thing. I mean, my technique there wasn't all that great either, but it should have taken it out. Should not have stripped it. I mean, it's partially stripped. All right, so just get a good firm grip on it. And I'll take it right out. Okay, new bolts come in the kit. Whatever you do, if you do install a Transgo shift kit, do not install the overdrive feed bolts that they give you. They're Allen head designs, and they strip out frequently. All right, got a mess right here in front of me. Let me get that bolt out first, and I'm gonna go ahead and clean up, and then we'll resume once I'm all cleaned up there. I'm looking for this friggin' socket where it usually is, and it's sitting right in front of me. All right, same thing with this. I imagine it's probably over torqued, so apply a little bit of pressure to avoid stripping it. A new one of those will also come in the kit. All right, let me clean this mess up right quick, and then we'll take the case apart. Check ball configuration, let me cover that before we do. So I gotta get those check balls out of there. I mean, they put Teardown in, that's always good. Teardown check balls won't wear the plate like the steel ones will. Okay, there's a total of 8 check balls, but depending on what you're doing with the transmission, you may end up only installing 4. So for high performance, you can delete the direct clutch check ball, that's just a flow control check ball, as well as the reverse check ball, that's here, direct's there. We have some check balls out of place. And then you're also going to delete the number 5 and number 6 if you have a block off plate for the 2, 3, 3, 4 accumulators. That's these 2 check balls here, you're not going to use them. You're not going to put them back in. Easier way to do this. Alright, so that'll allow much of the fluid that's, kind of still in the case and the worm track to drain a little bit. Keep this little pull spring in place while you're tearing down the unit so that the parking pole doesn't get in the way of you extracting the gear train once you get to that point. Otherwise, it might, you know, kind of become a hindrance. So like most transmission benches, this bench drains to the back. My other one drained to the front, which I don't like. I mean, I still have that bench, it's in the back shop, but if you're gonna buy a bench specific for, you know, working on transmissions, get a bench that drains to the rear. All right, 13 millimeter on the pump the case bolts. These get like 18 to 22 foot-pounds. There's little seals on each bolt. Alright, so what I like to do is come in with the pry bar and just, you know, wedge the pump out. I mean, you can use a pump removal tool as well if you don't want to deal with the pry bar. It looks like it's stuck a little bit. There it comes. Alright, turn this so it's facing you. So pump the case gasket, looks smoked. So here's your overdrive assembly, coast clutch drum, planet, etc., etc. And then we have our overdrive clutch housing along with the overdrive clutch. Appears to be smoked. We'll look at it shortly. Forward drum. Note the bearing and the hub. So this is going to be your rearward thrust washer that goes there. Direct clutch. It's always something gonna kind of foul me up here. Alright, look down a little bit. Then you got your coast band. So again, this is the wider band. And your intermediate clutch, looks like they reused the factory intermediate clutch snap ring. It is not recommended, not frankly for any build. I don't care what it is for, stock to pro mod, all out race, you know, top fuel drag car, whatever. Always replace that thing. Alright, intermediate clutch. Okay. And then you have your cushion plate. The cushion plate is something that was introduced in either 1995 or 96. And then you have the gear train. You know what? Got a center sport snapper I'm gonna take out. Duh! Duh! A little overeager. Getting a little too excited. And they got this thing clocked such that the back here, I'll just show it to you, but it would be easier. Whoever built this clocked the snap ring completely wrong in my view. Alright. So I like to have the ends gapped so that one end is roughly here and one end is roughly here. It actually makes it a lot easier to remove that way, and more importantly, it doesn't allow for nearly as much deflection in the snap ring as, you know, the way they have it. They have a good I'd say roughly 30% of that snap ring's diameter pretty much unsecured. So, you know, that's how a lot of these reman companies, they don't really care about these kinds of details, because it would add you know, add assembly time, and for them to make any money, because their margins are so thin, they really need to shave wherever they can, because while production costs are probably well managed, it's all of the non-prod costs that, you know, that really get you when it comes to large companies like Jasper and Monster and the like. All right. What a pain in the ass. All right. That was extremely sloppy, but there's a flat side and a beveled side. The beveled side faces out, faces front, faces you when you go to put it back in. What the hell's holding this thing in now? Okay, something I literally just noticed. Let me go change out the battery and I'll show you what's going on. Okay, so what we have here is an Allen head fastener that has been installed into the high reverse feed passage in the case and probably threaded into the center support. Let me zoom in. So right there. So that's what's holding everything from the center support on back into the case. So what I'm going to do is I'm going to take my impact driver that you saw just a few minutes ago, the 7/32 Allen head socket, and we're going to smack it out of there. I don't want to take chances with the impact. Who knows, you know, how much torque they put on that bolt, and you know what else might be going on. Maybe they put Loctite, and so that would be a real great candidate for stripping that out, and you know, basically renders the transmission useless. So let me reposition the camera again, and then we'll go ahead and start whacking at it with that impact driver and hammer. I want to make sure that I am firmly, you know, engaged on the fastener. Torque it slightly counterclockwise, and then start whacking on it. So we have ourselves a set screw. Neat. So they did dual feed the direct clutch in this thing. So now what I'm curious to know is whether or not they installed a center seal in the drum. So you know, we'll find out in a little bit. But now I should be able to get the gear train center support assembly and complex out of this thing, along with the anti-fretting ring and low reverse band. And I wonder if they rollerize the rear of the case. So let's find out. Let me see if I can reposition the camera, get a little bit better view, and then we'll finish out the case evacuation. Sloppy. Sloppy. So lost my grip. And we'll put that aside for now. And then you got the band in there. And you also have your anti-fretting ring. So the anti-fretting rings were introduced in the TH400 starting in 1972. 71 and back had a center support design that had thicker lugs, and they had no fretting ring. So if you're working on a TH400 those early years, the thing to do is either machine the existing center support or retro a later TH400 center support along with an anti-fretting ring into the case, so that you don't have that kind of wear happening between support and case as it's reacting and, you know, as the transmission's working. So band, let's grab it up. That band looks like it's smoked. Like I said, I can't remember what vehicle or, you know, what the story was behind how the vehicle was used, but I mean, you can see cracking here on the band. I mean, it is heavily worn. So I'm thinking this thing was raced. So here's another another what I would call good attribute. Let me get you so that you can stare right into the case, because we have what appears to be a reinforced bushing in the back. Okay, got the camera to focus. So what that appears to be is a reinforced bushing, and I don't see that too much. However, where Jasper went wrong here is they did not rollerize the rear of the case. So, is that mandatory to do for a stock to mild performance build? No. I do it on every single one because it's so cheap to do, but it's not mandatory. However, if this was built as like a stage 1 or 2 or whatever high performance type transmission, and that's how Jasper marketed and sold it, then not rollarizing the rear of the case is kind of a big omission on their part, especially given that they're clearly dual feeding the direct clutch. And just to be clear, when I say dual feeding the direct clutch, in most cases, while I fix this camera, that does not actually mean true dual feed. What it really means is we're allowing fluid to flow to the entirety of the underside of the direct clutch piston when in third gear. These transmissions are designed to have that entire piston used in reverse, as well as a true dual feed circuitry design. So you have fluid flowing into the direct clutch piston cavity from the direct clutch feed and the high reverse feed when the vehicle is put into reverse. But when you're making a 2-3 upshift in a normal forward pattern factory configured 480E and TH400, only the inner portion of the direct clutch piston is actually used. You know, the cavity, if you will, and not the outer perimeter portion. And that's kind of an omission, I think, on GM's part, or an opportunity to have done that differently, because dual feeding really improves the overall strength and torque handling capacity of these units. I mean, they don't have very many weaknesses, but that is one of them. That, the flimsy intermediate clutch snap ring, excessive end play in some of these units, and then some of the early 480Es, you know, the quirkiness associated with that torque compensator feed and vented Bosch EPC that was used. All right, so with the case empty, I'm going to go ahead and start going through the sub-assemblies, and we'll see what else was done, what maybe could have been done differently, what Jasper may have done that would be recommended, in other words, good on their part, and then we'll wrap up. All right, got a clean workspace, so start the band. As you can see, I mean, this thing is smoked, so it'll go in the trash. Got a chunk missing out of it here. Extreme wear at the apply points. Some shops consider this a hard part. In other words, they won't replace it unless it looks like this. But I consider this a soft part, so all my 480Es and TH400s get new reverse bands. I don't reuse that kind of stuff. Any friction material gets tossed. Okay, I'll never use the 3-tab selective spacer back there in the case, as it is replaced with a TH350 pump bearing and one or more shims. So very interesting here is that the center support has all of its sealing rings. Normally we would omit this sealing ring here, second from the top, in a quote-unquote dual feed setup. The bushing, I think, was replaced. So we have the top portion of our bearing assembly for the sun gear. This is the bearing race. So that's how it goes. Just throw that in there. I think this bushing was replaced. It does not look factory new to me. Okay, that other 4LADE that I did teardown inspection on, the one with the Jake's Performance Stage 1 kit or Stage 2 kit, none of the bushings in that one were replaced. So thrust washer, it's back right here. We can take this out. So just press on it until you can get up under it, and it'll come out. Not a lot of spring tension on these. So they're all high rate return springs, anything high performance. I always install all 12 springs, but Jake's with their kits, they actually tell you to omit 6 of the springs. So I don't know the reasoning behind it. I'm sure there is a good reason. I mean, he knows his stuff, but I don't know what it is. Okay, this is going to be a second design piston for the center supports for the 4LADEs that changed, I want to say, in '96. And then you're going to have your little seal for your return lube. That'll allow you to get your return fluids a little bit too wide. I'll deal with that seal later. Okay, check the sealing surface in here. Make sure it's not gouged, scored up, damaged in any way, kind of shape or form. Same with this journal. So any kind of gear train failures where you have metal floating in the case, same with torque converter failures, you'll have scoring on sealing surfaces. Same with the race for your low roller clutch assembly. So all one-way assemblies and all transmissions are to be replaced. There are a couple of exceptions to that, but for these, you replace all of them. So there were different designs of these as well. There was an early and a late. One design had legs, the other did not. This one has what's called a roller clutch support installed. So here's the other part of that sun gear bearing. And then your little support just comes out. And then this is it's like a 2-tab washer. So it goes right here on the output carrier, and the design changed. I don't remember what the year was. I'll annotate the video, but they went from a 4-tab washer there to a 2-tab washer. So the planets changed. In 1999, they changed the housing because they made the pinion gears longer, so meaning lengthwise, going like this. So these planets are not interchangeable with any 98 and back 4LADE or any year TH400. So that also applies to the sun gear and sun gear shaft. 99 and up, you can identify them via the ID grooves here and here. So this side faces front. Got your little lube hole, and you just line it up like so. Want to make sure that you have daylight poking through, and you can see that daylight. See it there? When you go back with it. Be prepared to clearance these bushings, all sun gear shafts, TH400 4LADE. Very, very rare that those bushings will install such that the intermediate shaft will pass through them and kind of quote-unquote mesh with them without binding up a little bit. So that's, unfortunately, it's considered normal. So I use 400 grit sandpaper to start, and then I finish it off with 800 and 1200 grit. You can also use a very small brake cone. Lyle makes one. They're available in any auto parts store, and it'll fit into that shaft. You just want to use slow speed and, you know, doing short controlled bursts, because you can take too much off. All right, so back to checking planets. Okay, there is a spec for the vertical travel, meaning, or I guess it's really horizontal travel, because the thing sits like this in the case. Okay, bushing is worn. That may be a factory bushing. All right, so here you're going to have your factory 4-tab thrust washer on the output shaft. So I get questions from time to time, or I see questions asked from time to time on internet forums. You know, can I interchange a two-wheel drive 480E and put it in a 4x4 application as long as I just change out the extension housing? Obviously, the answer to that question is no. This is the specific part that has to be changed if you want to convert a 4-wheel drive into a 2-wheel drive and vice versa. I mean, this is one of them. Okay, depending on what year, make, and model application, there may be, you know, more parts. But bottom line is that it's not as simple as simply exchanging output shafts, or excuse me, extension housings. You have to change out the output shaft as well. Alright, so let's take a look. So here is our output shaft. Let's see if this bushing is new or not. That doesn't look new to me. Alright. So here is the sun gear to ring gear thrust bearing assembly. And then for all 99 ups, they have a 41,000 shim in here. What this shim does is that it recenters the sun gear with the two planets so that you don't have an out of position situation, out of mesh situation in the rear gear set. They ain't gonna last very long if you do. Okay, small snap ring right here. And then we have our final thrust bearing. There's 3 of these, what I'll call detached or open style Torrington bearing assemblies in the rear of the case. So just be aware of where they go. We'll check that planet in a second. Windy out today, so sorry if I was distracting you. Right, let me go fetch that. Alright, can't stress how important it is to have an organized shop. The reason why I'm not worried about stuff falling onto the floor is because the floor is kept largely spotless at all times, so it's very easy to see where stuff goes. You know, I'm never going to lose a snap ring or a check ball or some other small part due to mess and clutter. So, snap ring there. And then for your ring gear, check splines, check journal, check teeth, check the base plate. Make sure nothing's awry with it. Bring this back real quick, look at the band surface. Okay, this band surface is actually not as bad as I was anticipating, given what we saw with the band itself. You run your fingers along the surface like this, and if you don't feel grooves, that's a good sign. Next thing you're going to want to do is take a straight edge and a flashlight, and then shine your flashlight like so, have the straight edge, and see if any light is poking out from underneath the straight edge. If so, you're going to want to turn the drum, or the band surface rather. Don't have access to a machinist or a lathe, then you can just replace it with a good used one. Okay, same with the shaft. Check your journals, check your splines. Notice this shaft is solid. The early first generation 480s, 91 to 96, the shaft here was hollow. It means you can see straight through it. So again, that's part of the center loop design change. So 1998 and back, front and rear planets will retro to any year 480E and possibly TH400. The 99 and up planets will not retro. Okay. Now you can take an entire service pack, the entire rear gear set, all the bearings, the intermediate shaft, sun gear, center support, that 41 thou spacer and your output shaft, and stick it in a 97 or 98 unit and be perfectly fine, as long as it all goes as one service pack, one entire sub-assembly. So just keep that in mind. Alright, so teeth on the ring gear here look okay. Always check your pinions, and the same applies to that and the overdrive plan, and make sure that none of them are loose. Make sure none of them are burnt. So 4L85Es had 5 pinion planets, front and rear. So let me talk real quick about the very early 4x4 units. So to bring back what I was saying at the very beginning of the video, when it comes to interchangeability and speed sensor configuration, the very early 91 through 1993 4x4 units had an output carrier with a tone ring. This is what the rear speed sensor reads. That's what it picks up. 94 and up, this was deleted in the 4x4 units. So if you have a 91 to 93 4L80 4x4 and you're looking for a used good unit, you really can't use anything other than another 1991 to 1993 4x4 4L80E. 94 and up, they deleted this. I believe they still installed the speed sensor, but nothing went to it, or if a wire was there, it was non-functioning. In other words, the PCM wasn't looking for that output speed sensor. It was only looking for the input speed sensor and the vehicle speed sensor in the transfer case. So close the loop on that aspect of the 4L80E. Okay. Output shaft splines, check journal. Make sure, again, no grooves are present. Got the race portion of that bearing. Like I said, I think this is a factory. I don't think that bushing was replaced. So looks like they replaced only the center support bushing, at least in the rear train. So these clutches are a little bit stressed, but nothing crazy. Say some slip marks. You can see on each one has a slip mark. I would consider that to be normal for something with a lot of miles on it, but you know, something with only 40K, assuming a normal daily driven application, I would not expect to see that. But then again, you never know how this vehicle was used. At least I have no idea. Alright, direct clutch. So in the direct clutch, you want to shoot for a clearance between 50 and 70 thousandths of an inch. Any more than that, to the extent you can, try to dial it in. Okay, 5 and 5, and this is fairly well smoked. So a lot of folks will tell you that you should never run a cushion or wave plate in a high performance application. It's actually not true. Talking with Chris Kirkonis of CK Performance, he often runs wave plates in applications making like 600, 700, 800 horsepower, because he says that it actually, and I don't know what the right word is here, but like it allows for a smoother transition from 2 to 3, where the shift itself still feels perfectly crisp and timely, but it's, you know, it kind of alleviates some of the shock and actually helps propel the vehicle forward a little bit. That's literally how he described it to me. So don't be afraid to use cushion plates. Now with that said, some of the designs of these cushion plates, I think the conical type tend to break. So if you're going to run a cushion plate, run this style. The other thing to make note is that the cushion plate in the direct clutch is different than the cushion plate in the forward clutch. You know, the height between the trough and the crest is different. So just be aware of that. You may or may not want to, you know, mix them up. Toasty. So you see all the slip marks here. So I'm not sure exactly what Jasper is accomplishing by putting that set screw in there. Like I said, I would take a guess that the center seal in the drum is not there. At least it shouldn't be. Otherwise, the transmission couldn't have possibly worked right. I need to eyeball that separator plate too. Maybe they're using a proprietary plate and that's kind of what's throwing me. All right, let's go to the press and take out that snap ring. All right, we have everything kind of set up. So just gonna go ahead and remove the snap ring. Maybe. There we go. It was a little awkward, but it got done. All right, in case you're wondering what these tools are, this thing's actually a race for a bearing in the back of a 6R140 transmission, and then this thing's available on eBay through a seller's transmission jobber supply. So transmission jobber supply. These are 75 bucks, and then you can buy one of them where any transmission parts are sold. Alright, so I like to protect the return spring assembly, and I've since relocated my foot press to the back shop because I like to use this press for everything. Alright, so let's see. Alright, no seal, that's good news. That would have been really, really weird if a seal was present there. I would have had to have figured out exactly how that transmission was functioning if there was a seal in that drum. Alright, back to the bench. Alright, I'm going to have to change battery out after this, but just take a quick look at the direct piston. So this is National brand seal, this is OEM, and they label the pistons so you can differentiate the direct piston from the forward piston thusly. So, checking the sealing surface here for both of these lip seals. They appear to be fine, so slippage is likely due to just either too much power being put into this clutch, and it was just causing it to slip under wide open throttle situations, or the hydraulics of this transmission are no good. So jury's going to be out on that as far as this video is concerned. Like I said, I'll do another video, and once that valve body's cleaned up, reassembled as it is now, I'm not going to put any corrective or performance valves or whatever in there. We'll go ahead and we'll do a video testing it without the use of the Sonex test plates. I've got a couple requests actually to do a video without using that test plate because, as I mentioned earlier, it's likely that those plates are going to go away, and most do-it-yourselfers aren't going to spend the money for them anyway because, frankly, they're not necessary. I just do it because it's convenient. Alright, so sprite rotation, freewheels clockwise, locks counterclockwise. So if this thing fails, then you're not going to have second gear, and you're also going to slip real bad in third, and transmission will need to be overhauled. So you want to retro a spiral lock ring like this into any kind of TH400 where you're doing some sort of high performance type application, high RPMs. It's always good to have something better than what comes in those things from the factory, which is just a traditional snap ring. And I'm not saying that is like prone to popping out, but I just like the extra added protection that this spiral lock snap ring will give you. So 34 element heavy duty sprag. If you are going balls to the walls when it comes to power output, you can opt for what's called a super drum, so 36 elements, and you can either go billet steel or billet aluminum. If you're racing, billet aluminum is recommended simply because the transmission will have to come out for refresh periodically, but it's less rotating mass, and so a little bit more horsepower is preserved, and every little bit helps in a racing situation. These grooves have to face you when this thing is put back on. Okay, I just wanted to make sure it wasn't backwards. It couldn't have been because I haven't removed this yet. So when you're putting these on, the thing to do is to take the sprag out of the package and stick it in the race like this. Just put it in there. It's a lot easier to get it into the race, despite what you see me doing here, fumbling around with it. Once it's installed, it'll go onto the drum a lot easier versus you trying to put it on the drum, then installing the race over it. That's always the more difficult or cumbersome of the two approaches. Check the area in here for sealing ring groove wear. Okay, I see visually a lot of wear in here, but I also think, based on what I'm seeing in here, is somebody took sandpaper or something and they, you know, kind of went over this area in the inner diameter. You can also see some, clean that up a little bit. Yeah, I thought I saw an additional wear spot, but it was just dirt. Check the splines. Check the you know, the race here. Make sure it's mirrory smooth. You'll notice there's a lot of slippage on the band surface with the coast band. Coast band looked like it was pretty tore up as well. So high performance. Always drill like anywhere from a 40 to 60 thousandths bleed hole to provide additional exhaust capability to that clutch in real high RPM, so you don't centrifugally apply it in first and second gear, especially first gear. All right, let's drag over the forward drum. So forward drum clutch clearance should be somewhere in the neighborhood of 40 to 70 thousandths. I like to stay between 40 and 60. And let's see, we see another smoked clutch. Pressure plate slash direct clutch hub looks okay. There are billet versions of those, same with the hub. So high performance, you want a billet forward clutch hub for anything, I would say, north of 600 horse. The 480Es, especially the late models, they're a little bit more resilient than the TH400s from what I've seen when it comes to the billet forward clutch hub. TH400s, if power levels are in excess of 500, I will install one of those billet steel hubs. Alright, so what the hell's the story here? What do I have? Why do I have one friction and two steels? Smoked. Freshly charbroiled. Was that the stack up? So you got one half decent friction on that side, this side's burnt. Two steels. These are 77 thou thick. The direct clutch steels are 90 thousandths thick. At least that's the factory spec steels. And this thing's badly coned. Okay, there's a specific reason why this happens with these transmissions. We'll talk about that in a second, if you don't already know. Yeah, I think this was the stack up, so let's see if it makes sense. So here's your cushion plate. This is different than the one that came out of the direct clutch. You know, it's calibrated differently insofar as its cushioning effect upon apply. Get in there. Right, that one's coned. If you're OCD, line up these tabs with each other on all the steels. I will tend to do that. I'll make sure I line up that little notch too. And again, I don't know how critically important it is. To be honest, I mean, I've only started doing it relatively recently, so. Yeah, that's how it was built. I'm not a fan of doing this, to be clear, but I don't think it's necessarily detrimental. I mean, it's not why this clutch burnt to the ground. Okay, because somebody put two steels next to each other like that will not cause a failure by itself. So this part of the bearing faces you. All right, so let's talk about why this could happen, at least when it comes to the forward drum itself. So this inner diameter here is very vulnerable to sealing ring groove wear as a result of the input shaft wearing into it. And I can't really tell here in that it's, you know, because it's so dirty, but when I clean this off, I'll inspect it, maybe take a picture, and I'll try to include it in the video. But when this inner diameter wears real bad, you will have this as a result. And you will eventually start slipping when the wear progresses to the extent that you have enough fluid blow by. This drum can no longer hold pressure, and then eventually, if it's left untreated, it will burn up the clutch completely and you will lose all forward movement altogether, and that will be that. So nothing here is reusable. I mean, not that you would reuse steels in a complete overhaul anyway. I mean, I always install a steel module in these transmissions. Like, I'm not even going to reuse this. It's, to me, scrap. So I'll take out the piston later. I mean, the only thing really noteworthy is the inner seal in the drum. They can be tough to get off. I use a 2-jaw puller and something here to, you know, kind of work with the forcing screw, and that yanks it out. In a stock rebuild, if you can't take it out and or, you know, you don't have the tools, don't worry about it. It's not the end of the world. High performance, you want to take it out and leave it out. Don't put anything else in there, because that allows for quicker clutch apply, especially on like you know, trans brake type applications, or when you're launching off the line. But I've heard builders say that there's a case for leaving them in as well, regardless of what you're doing. So here are the 2 sealing rings that wear the forward drum. One other thing I'll make note of is, that's a direct drum. In the forward drum, you can purchase an oversized wide bushing there. So the bushing that goes in the forward drum, Omega Machine makes a wide bushing in that location, or for that location. So that will allow you to you know, kind of install something that's a little bit more robust. So these things. Let's see if they work. No, I'll grab other pliers. Alright, that's good. So, as I mentioned earlier, this snap ring and the snap ring groove, the space between them needs to be netted out of your front end plate measurement. So, from the factory, you have about 20 to 25 thousandths, sometimes 30 thousandths of play there, but billet aftermarket shafts tighten that up considerably. So for the shaft itself, you're going to check splines, you're going to check your journals, as we can see here. A lot of hard bushing contact is evident, so this thing may have been ran low on fluid, and, you know, either nobody caught it in time or they just didn't care. I mean, it's almost impossible to say, but these shafts are good up to about maybe 750, maybe 800 horsepower, but I'm a fan of adding a billet steel shaft once power levels cross that 700 horse threshold, and racing is going to be part of the usage pattern. Alright, overdrive assembly. So this is another area where we had an engineering change. So the housing and the apply plate or backing plate changed to, as well as the case, to incorporate this stabilizer boss. And they had a pin there that you saw earlier, and that pin allowed this plate to be a little bit more stable and its movement to be a little bit, you know, better well managed, if you will, compared to the earlier design. So that changed in '99. So '99 was a big year for these units in terms of engineering changes. A lot of things were made different. So, you know, you got to know your interchange rules when it comes to your various parts inside these transmissions. So, steels are smoked, clutches are smoked. Off to the scrapyard. I would not reuse this either. My guess is it's not warped. I'm going to clean it off just so I can actually confirm or deny that. But if any of your apply plates, backing plates, and or steels look like the ones coming out of this transmission, then do not reuse. Always replace. All right, for this thing, it just comes apart. Gotta find the end of the snap ring here, right there. So you could take it apart and put it back together. We'll go through this drum in a second, and I'll talk about the roller assembly design change that occurred in 2001. Looks like they retroed an earlier first design, which is actually a good thing. So let me see if I can get this thing apart, and then we'll look at the lip seal surface to see if there's like anything that I could learn, anything that would explain the condition of that clutch by just simply studying the lip seals. Alright, so how you see me taking this out is exactly how it's going to go back in. So you're going to use your forward drum or your direct drum. I actually like to use the forward drum. You're going to sit this half on the drum, position it like this with your new lip seals. Okay, note the way they're facing. This lip faces this way, this lip is facing this way. Alright, then what you're going to do is you're going to, coat them with assembly lube, and then use your lip seal tool to get the lip seal in all the way around on this side. And then what I do is I take it and put it at the edge of the bench, and I come up from underneath with the lip seal tool, and I collapse the lip seal and get it inside the lip seal surface on the underside. Once you do that, you'll be able to stick this back on top. You'll have the snap ring groove exposed, and then all you're going to do is compress it down and gradually install the snap ring all the way around. You don't need any special tools to assemble the overdrive piston and piston housing deal. Pretty simple. Let's talk overdrive section. So here is our planet. We'll check it. Unlike most other planetaries, you can actually service this planet almost completely. Like, unless it's totally destroyed, you can recondition it. So all you would need to do is remove the snap ring here, and then you can remove all of these internal parts, including your pinion gears, replace needle bearings, replace gears, your little washers, and all that stuff. So unless the housing's cracked or something, or there's something else about it, like this bearing can be replaced. This race can be changed out as well. As you can see, it's not actually a part of the housing itself. It's pressed into the housing. So once this is all apart and you have access, this plate's off and whatever, you see these pinions, they're not going to be there anymore. You can take a drift and punch this out and put a different race in there if you need to. So for robust supply chains like those in the United States and Canada and other places, that's usually not necessary. But if you're in like a foreign country where supplies are not nearly as prevalent, not nearly as readily available, then that may be an option for you. Take like 2 good planetary assemblies and make one that actually is viable. All right, so let's talk interchangeability and design change of this drum, this roller assembly, and this race. So what you have here in front of you is a service pack. Okay, doesn't count the input shaft, but the planet, well, specifically the race, the cam here on the drum, and the assembly itself all changed, and that change occurred in the year 2001. In 2001, they went to a thinner roller in the roller clutch assembly, because I think GM was saying that this would deflect at higher RPM. Now, many builders have the exact opposite opinion, and they feel that this is actually the better design for heavy duty and high performance. And I tend to agree, because the rollers are thicker. I've never had somebody tell me or had one of these fail because I did a prospective install on a later model unit, a higher horsepower, or street strip type application, because of this design being somehow deficient. So if you're going to want to make that change, you got to make the change as a service pack or at the service pack level. Okay, You can't just put this on a later drum, or vice versa, it won't work. And you'll lose all movement if the roller clutch fails. So it looks like we got a couple of smoke frictions in here, 2 out of 3, actually 3 out of 3, 2.5 out of 3, I guess, if you want to count each side. So these all have something that indicates which side goes which. This says up. Okay, the backing plate itself doesn't look too bad. There's top friction, the steel is burnt. Second friction is burnt, steel is burnt. Third friction is burnt. So these are no good. To the scrapyard they go. Alright, this snap ring is a pain in the ass. You want to use large snap ring pliers to deal with it. So medium style snap ring pliers like these are in most cases not sufficient unless you are really good, and I am not really good, as you've seen. So this is what I use. Okay, these dwarf these, and the reason why you want these is because this snap ring loves to contort itself. Once you get it to the point where it's almost ready to come out of the groove entirely, it will contort significantly on you and kind of twist itself up like a pretzel. And so having much larger pliers to handle that kind of twisting will make the job a lot easier of R&Ring that stupid thing. These bushings were not changed, they're original, I can tell. Original bushings. Alright, last sub-assembly we're going to look at today is the pump, or at least in this video. I'm curious to see what, if anything, was done with the pump. Alright, so before we begin, there is important information you need to know when it comes to 1997 through 2007 480Es as it relates to the pump cover design and the case design. So there were 2 different variations in production during this time period. And I will flash a chart on the screen that will just give you all the information visually, because it's a lot easier versus me trying to explain it. But if you need to change either the case and or the pump cover, you need to make sure you're matching those 2 things with respect to each other when it comes to the 2 possible designs. And it has to do with the feed holes here for the cooler, the cooler circuits, cooler line circuits. So again, I'll have the chart on the screen, you can check it out, but I just wanted to make sure you were aware. Alright, this bushing again does not look like it was changed to me. Maybe it was, but I mean that's kind of a big no-no, especially with these things. The pump bushings tend to wear in the stator and the body, and so if somebody like Jasper or Monster or any transmission builder, local transmission shop, they're not changing the bushings, then they're setting the transmission up for early and often failure. Alright, so you have your selective washer or spacer. Many different thicknesses are available. If I have a chart handy, I'll flash it across the screen. So that's how you ultimately dial in your end play. Looks like they use old school 1-piece Teflon sealing rings here. I have found that when these are used, they actually tend to wear out a little bit faster. And I used to use them a while back, but I've stopped. I just use what comes in the kits now. It's the plastic interlock style sealing rings, and they actually work a lot better in my experience. Many times when I do air checks on components that come in with these rings on them, they leak real bad. And that could explain why the coast clutch was burnt. 13 millimeter. Alright, later pumps had this thing. I don't know what the hell it is or what it's called. And it doesn't want to seem to come out. If you guys know, by all means, go ahead, post it. I'd be interested, as I'm sure will others. Alright, let's take a look at this pump. Oops, sorry about that. Alright, here is the pump cover stator assembly. So it's this half here, this casting, that changed during, or at least, you know, there were two different versions of this in production between 97 and 2007. What the hell happened to my rags? Alright. So it looks like some excavation work occurred here. I mean, this is an absolute disaster. Disaster! So, I could take this pump to my machinist, at least, you know, this half of it, and get his opinion to see if this is salvageable. I mean, I guess, yeah, technically, you can take enough off of it to get one unified flat surface again, but, I mean, this is, like, visually pretty prominent. You know, this is like the equivalent of a cliff face in, you know, anywhere else. I mean, we're talking about transmissions and surfaces, so I don't know. My guess is probably not, but that's pretty severe. All right, I'm going to take out the pressure regulator and boost valve. I'm curious to see if Jasper replaced the boost assembly at all. It's something that you really need to do on these transmissions. Do not ever reuse factory boost valves in TH400s and 480Es because they wear aggressively and you will have either extremely low line pressure or extremely high line pressure as a result. Alright, we got part way. It did not want to willingly come out. So you saw what I kind of did with the pick to get the O-ring out of the way. So they did put a Sonex boost valve, good on them. So we have our factory washer. This is probably a Sonex spring, and it doesn't look like a factory spring. And then you have your bumper spring for the boost valve itself. So that one's wanting to get away from me. And you got your pressure regulator valve. So you see a little bit of wear on the inboard land. So Sonex makes line to lube or lube regulated pressure regulator valves. So I'll have to study this, but I think this actually might be a Sonex valve. Definitely has wear to it. And then right here is where you would drill your 55 thou line to lube hole if you were going through this unit and reinstalling the factory pressure regulator valve. Do not do that under any circumstances if you're installing the Sonex pressure regulator valve. If you do, you'll have likely excessive, I guess, volume flow or fluid flow through here and through the valve itself in that circuit, such that it will adversely affect lube pressure and you may not get adequate lube to all your parts and components. Okay, I have a separate video that goes through lube modifications for these transmissions, so you can check that out if you'd like. They involve this little hole here that I just described. It's also a good idea to drill this out 1/8 so that you can enhance lubrication fluid flow to your overdrive roller assembly. And then in the pump body, you'll want to drill out the drain back to 1/4 of an inch. So let's see what they have here. This is a drive and driven gear set. You can reuse the factory gears if they're in good shape. So what you would look for is condition of these flats. I've seen them come in very mushroomed so that they would not re-engage the torque converter properly. And the pump and the converter, like the converter would not slide all the way in toward the pump. Here it looks like we had the exact opposite situation. You know, not enough clearance, so maybe they shimmed this thing on their flex plate and they over shimmed it. And there could be other possibilities as well. So looks like a bushing was installed that is you know, different from the factory. So it's a ventilated bushing or a drilled bushing that allows for more lubrication to gather in that area. Alright, let me pop out that seal and we can see if they drilled the drain back at all. So I just get like a chisel like so, kind of wedge it in there and behind the seal. And pop it out. They did not. For a performance build, I would have done that. I don't know what the diameter is from the factory. It's probably like 1/8 or something, but I would have drilled that out. That's another one of my lube mods I cover in that video where I actually show you how to do it, you know, with the drill bit and all that whatnot. I talk about the, and show you the hole there for the direct drum. Here on the overdrive drum right in this location, this is to be drilled 1/8. Let's take a look at working surfaces and crescent. Alright, so we got a lot of crescent wear, very obvious. Working surface has some scoring right up in here, but I guess at first glance, with that dirty, you know, dirty pump body, I don't see too much in the way of other damage. I mean, I'll have to inspect it for real once it's all cleaned off. But when you see that in combination with asymmetric bushing wear, which we kind of see where the wear is concentrated on one side or one part of the bushing. That could indicate main bearing wear in the engine. So crankshaft, as it's kind of oscillating, you know, in the main bore there, your main line, it's taken the flex plate and the converter with it, so everything's force thrusting against the crescent, and that will wear the transmission, you know, and destroy the pump if it's really, really bad. So, somebody had made a comment on one of my other videos, 4LADE, someone I know builds transmissions, I think Billy Williker is his name. He had pointed that out. My machinist told me the same thing about that particular unit. And here I'm talking about that Jake's Performance Stage 2 teardown. You know, when I showed him the pump and you know, he brought the converter to him, he said, ask the customer if he had any engine work done recently, or you know, if he knows the condition of the main bearings, because it looked to him as well like there could be main bearing wear there. All right, so what the hell happened here? I think we have an obvious explanation for why this thing was smoked, why every single clutch and band was burnt to a crisp, and that of course is the excavation that occurred here on the pump cover. Now, the $64 million question is, why did this happen? What led to this? What caused it? And was it something inside the unit, or was it something external? So I talked about, you know, main bearing wear being a possibility, and you know, having the converter not being on a true center line and causing, you know, problems with the crescent, you know, in the body half. But that doesn't really explain this. I mean, this is basically like a canyon, you know, with this being a plateau. So recall back in the beginning of the video, we had the converter on the bench, and it's in the thumbnail too. And I believe that that is the source of the problem. Nothing wrong with the converter itself, but the specific converter that was used in this transmission. So let's go to the other bench real quick, and we'll take a look at that converter and compare it to another converter that's a little bit different. Okay, so I don't know how well known this is, but I didn't realize it until, I've been doing 4LEDs for quite some time. I had done maybe 10 to 15 transmissions before I discovered that were two different kinds of converters made, or I should say there were two different hubs used on 4LEDE converters through the years. So technically there was 4 different variants from the factory. Okay, so we have a short hub, and then we have a tall hub, or short and long. So the short hub design has a hub that's I think 2 or just over 2 inches in overall height, and then we have a longer hub design, which is about a 1/2 inch longer than the short hub design. I'll flash a chart that shows all the different converters that were produced and made available by GM on 4LEDE equipped vehicles, but suffice to say, I think that somebody, whoever put this transmission into the vehicle, used the wrong converter. They used a tall hub converter when they should have used a short hub converter, and as a result they had basically an interference fit between the converter flex plate, engine, and the transmission, specifically the pump cover, or stator support. And that is what excavated all that material. Looking at the snout of the hub, I actually don't see any damage. I mean, there's like a little something right there. So not real obvious. If I can get a little bit closer. These things are kind of heavy, so can't hold it indefinitely, but suffice to say, that's my working theory. I can't think of any other reason why somebody would have excavated and dug out the pump cover like that, with some sort of failure inside the transmission. And I didn't see anything that catastrophically failed, where shrapnel would have been, circulating at high speeds throughout the unit on, some continuous basis for any length of time. I mean, this is the only thing I could think of. We have journal wear here on this side, so that may or may not be related to this. The vehicle may have had a heavily worn out engine as well, so there may have been 2 things going on here that contributed to the demise of that pump. But the only times that I have seen a stator come in looking like that in any transmission, not just 4LEDs, but anything, it's always due to insufficient or no clearance between the hub and the stator working surface, or stator support working surface. And it just digs it out and basically clearances it. And once it was clearanced, there was so much material removed that line pressures had to have dropped through the floor. And you saw what happens when line pressure is not sufficient. So that's the working theory. If you guys have other ideas, or you think something else may have happened, please go ahead and put it in the comments. I'd be very curious to hear your thoughts on it. I try to film the teardowns where maybe something interesting has occurred, or I think that there'll be a good case study to kind of sink your teeth into, and play detective, if you will, because if you're doing this for a living, you're going to see all kinds of things, especially if you're doing transmissions on a carry-out basis for a living like I am. I never see the vehicles, so I can't just step into the bay and look at the truck or car or whatever and have all that body of evidence in front of me to examine, to try and piece everything as far as the puzzle together where it makes sense. So anyway, I believe this is what happened. At least this is my chief suspect. More than likely a short hub design should have been used. Somebody didn't check the spacing, or they thought that was normal. I don't know how you can miss something like that, but if it wasn't this particular converter, maybe this was swapped in place just to see if the transmission could be salvaged. Maybe they thought that the torque converter was bad. and they just simply put a new converter and repeated the same problem. But with this converter, it doesn't have any gouge marks because all the clearancing work has already been done, and that's why, for the most part, this looks unmarred. So this is not really a Jasper problem. Jasper remans transmissions. As far as I know, they don't do installs. So, you know, in light of this, I think while Jasper certainly could have done some things differently with this transmission, like replace electricals, all the bushings, you know, put the center support snap ring in the right way, you know, I can't really say that they did anything from a procedural perspective that would have led to this. I think this was all after the transmission was built and put back in the vehicle. Alright guys, thanks so much for watching. Greatly appreciate it. If you have anything else you want to see in more detail when it comes to 4LEDs, just let me know in the comments, and I will do what I can to prioritize a video for you. Till then, enjoy the rest of your day or evening, and once again, thank you so much for all of your time and your views.